Question A2, data analysis question. A small sphere rolls down a track of constant length AB. The sphere is released from rest at A. The time t that the sphere takes to roll down AB is measured for different values of height h. So I think you can understand that situation. A student suggests that t is proportional to 1 over h. To test this hypothesis, a graph t against 1 over h is plotted as shown on the axes below. The uncertainty in t is shown and the uncertainty in 1 over h is negligible. So A1, draw the straight line. So there it's telling us that this is a straight line, so you're going to need to use a ruler that best fits the data. So you need to draw a straight line that goes through all the error bars of these points. Now it's not easy for me to draw it because I'm using this pen and there's no ways I'm going to draw a straight line here, but you obviously do a much better job with me because you'll be using a ruler. So imagine that as a straight line going through all the error bars of all the points, and you'll get 1 mark for that. State why the data do not support the hypothesis. Well, we can see here it's going through the y-axis here. To be a direct proportion, it would need to go through the origin and also go through all the error bars. So it does not go through the 0, 0 point. Going on to the B part, another student suggests that the relationship between t and h is of the form t is equal to k square root of 1 over h, where k is a constant. To test whether or not the data supports this relation, a graph of t squared against 1 over h is plotted as shown below. The best fit line takes into account the uncertainties for all the data points. So we have t squared is equal to k squared 1 over h. So obviously our y is our t squared and our x is our 1 over h, and this will be our m. So the slope is equal to k squared. So firstly, the uncertainty in t squared for the data where 1 over h is 10 meters to the negative 1 is shown as an error bar in the graph. State the value of the uncertainty t squared for 1 over h is equal to 10m to the negative 1. Well, here we're going to be from this point, your error bar is from that point to that point there, like that. Now, in looking at that, it works out to be about 0.35, and it will be seconds squared, and this will be plus minus, so that would be your error. Calculate the uncertainty in t squared. T is equal to 0.8 plus minus 0.1 s. Give your answer to an approximate number of significant digits. So to do this, we need to go to our data booklet and bring our data booklet up here. And we'll be using this formula here, where we're going to have our error in t squared over t is equal to our error in t over t plus our error in t over t, where these are our absolute errors. So we're going to have our error in t squared, sorry, this should be a squared here, is equal to t squared times this, and that's going to be 2 error in t over t because they got common denominators, so I can just add them together. That will obviously cancel with that, and so I'm going to get 0.8 times 2 times 0.1. And when I do that, obviously I'm going to get 0.16. 0.16. And now it says to appropriate number of significant digits. And you can see here all of these are to one significant figure. So my answer will actually be 0.2, and it's going to be s squared. So there we have that one. Going on here, use the graph to determine the value of k. Do not calculate its uncertainty. So we just want the value of k. Now, as we said here, the slope of this graph is equal to k squared. So I'm going to find the slope of this graph. Now, I'm probably going to use the whole thing because you can use the whole graph here, and that's pretty straightforward. You want to use at least half the graph, but I'm going to go all the way. So that's 3.5, I would say, all the way up. And all the way at the bottom is 12. So I'm going to do this on the calculator. It's going to be 3.5 divided by 12. And I get 0.2916. So my m is equal to 3.5 over 12, which is equal to 0.2917 for the moment. Then I'm going to take the square root of that because your k squared is equal to m, so k will be the square root of m. So I'm going to take the square root of my answer, and I get 0.54. So my k, which is equal to the square root of m, is equal to 0.54. And I'll leave it like that. Now it says over here state the unit of k, so we've got the value of k here. So our unit, obviously, when finding the slope, we had this, which was s squared divided by meters to the -1. So our slope is going to have a unit meters seconds to the squared. And so when I found k, which is equal to the square root of m, I'm going to have to take the square root of that for k to find the unit for k. So that's going to be m to the half seconds. So my unit will be m to the half seconds.